Hi, welcome to another Azure Arc Jumpstart demo. Today, I'll be showing how we can use Azure Arc-enabled data services to deploy a SQL Managed Instance on a Google Kubernetes Engine cluster by using a Terraform plan. If you want to see more great Azure Arc content, be sure to like and subscribe. I've got the Azure Arc Jumpstart website open to the specific scenario that we will need to deploy the SQL Managed Instance on Google Kubernetes Engine with Terraform. As part of the deployment process, which you can see here, some of the first steps that are prerequisites are to configure our Google Cloud Platform environment with a new project and with the appropriate access and management rights and service account that we'll need for Terraform to create resources in GCP. As part of those prerequisites, which are all outlined inside the scenario here, we'll also be doing things like downloading the GCP credentials file that we'll create, cloning the Jumpstart repository to our local environment, and editing some basic configuration variables that Terraform will use. And then from there, we'll go ahead and start to run the Terraform commands to initiate the deployment of the resources. And then finally, we'll remote into the client machine that's created as part of the Terraform plan. And that client machine is where the rest of the Jumpstart automation will take over to finish configuring the environment with the SQL Managed Instance on GKE. So some of these prerequisites I've already done in advance of the demo, just to save some time. And that includes creating the Google Cloud Platform project, setting up the appropriate permissions, cloning down the Jumpstart repository, and editing the TF var variable values. Let's go ahead and switch over to a terminal window. You can see here that I've got my terminal window open. I've got the Jumpstart repository already cloned down, and I've navigated to the folder where the specific GKE with Terraform and SQL Managed Instance scenario resides. So if I look at the contents of this folder, you can see a number of files. Let's look at them a little bit more formatted fashion here. And as I mentioned, one of the steps that's in the prerequisites that's all outlined inside the Jumpstart scenario is to configure some basic environment variables. And the Jumpstart scenario provides an example file for you to use when you're putting your own environment variables in. Let's take a look at that example file now. It's called TF var data controller SQLMI example. And you can see that inside this variables file, we've got a number of variables that Terraform will use to help run the Terraform plan and configure the environment. I'll quickly go through some of these. The GCP project ID is simply the name of our GCP project that we create as part of the prerequisites. GCP credentials file is a file that we download to our local environment from GCP that contains the appropriate access management rights to create resources in GCP. You can see that file is already in my Terraform folder, so you'll want to make sure that you've downloaded that file and put it in your own Terraform folder. And you can also see some other variables that we're using. I've left most of these as default. Remember, this is just an example file we're looking at, but for the most part, the defaults should be fine, including things like the GCP region, the admin username and password, the cluster node count, the Windows username and password, and finally, the SPN client ID and client secret we'll want to provide our own values for. Now, these are just example values. As part of the prerequisites, we explain how to create a new service principal name and secret in Azure. You'll want to put your values for your service principal inside your own TFVAR variables file. You'll also want to make sure that you input your subscription ID, your Azure subscription ID here, and that you have the appropriate rights in that subscription to create the resource. And again, all of this is outlined as part of the prerequisites inside the Jumpstart scenario. So the rest of the aside from the service principal and the subscription variable values, for the most part, you can typically leave the rest of the variables as they are. So as I mentioned, I also have gone ahead and pre-configured my environment for the demo with my own values, and that's what I have in this tfvar file, this tfvar.sh file. So I'll go ahead and I'll run sh tfvar.sh. that's going to go ahead and export the local variables to my local shell that Terraform is going to use to run the plan. So the next step is for me to go ahead and initialize Terraform. So I'll run Terraform init. That's going to go ahead and download the resource providers that Terraform needs to create the resources in both GKE and in Google, and in Azure. I'll also next run Terraform plan. Terraform plan is just going to go through the Terraform configuration and plan that we've created and ensure that everything, including the variables, are available to Terraform. And it'll effectively, what Terraform plan does is it tells us what it's going to create when we run Terraform apply. You can see in this Terraform plan, we've got 8 resources that we'll create. That includes resources in GCP and in Azure. And it won't change anything and it won't destroy anything because there's nothing to change or destroy at this point. So our next step, since our plan looks good, I'm going to go ahead and run Terraform apply, and I'll specify auto approve as a command line argument just so it doesn't prompt me to approve anything, and I'll hit enter. And so now we'll wait for the Terraform plan to apply. This will take several minutes, so we'll go on mute for a little while we observe the progress, and we'll come back when the Terraform plan is complete and go ahead and proceed with the next steps of the deployment. Okay, so now that the Terraform plan is finished, we can use the public IP that the plan outputs and remote desktop into that IP as part of the next step in our automation. Let's pull up a remote desktop window. Let's paste in that public IP address and connect to the desktop. Now I'm going to specify the username and the password that I had input into my Terraform variables. That should give me access to the desktop. Once we log into the desktop, the next step of the automation is going to kick off. Go ahead and minimize that window there. And we'll take a look at some of the scripts that run as part of the desktop, or as part of the automation to configure the SQL Managed Instance on our GKE cluster. You can see that on first login, there's a couple PowerShell scripts that are going to run. I'm going to reposition some of these scripts here. And we see the script that is running now. It'll start to record the output of the script to the path here. So we'll have a log to look at in case anything goes wrong. And the script will continue to run to go ahead and configure the SQL Managed Instance. Now, while this is going to take a few minutes to run, so while that's running, let's go switch back to the browser. Let's look at our Google Cloud console and take a look at some of the resources that got created as part of the Terraform plan. Now, if I go into the compute engine of our GCP project, we can see that we created a virtual machine. That's the virtual machine we just remoted into. And there's some nodes as well that are part of the GKE cluster. I can also look at the Kubernetes engine and see the cluster itself. So this is the actual GKE cluster that we have connected to Azure Arc as an Azure Arc-enabled cluster that we're now going to be deploying the resources on. On the same side, if I go to the Azure portal and open up the resource group Arc Data GKE demo, we see that the Terraform plan also created an empty resource group. Now, as part of the automation is going to go ahead and connect this as an Azure Arc-enabled Kubernetes cluster. It's going to create a custom location. It's going to create the data controller and the SQL Managed Instance as part of Azure Arc-enabled data services, and these will all be visible when the automation is complete. For now, let's go ahead and just monitor the automation. As I said, it'll take a few minutes to complete this automation. You can either monitor the automation directly inside the VM, like we're doing here, or you can review it afterwards in the output log that I talked about earlier at c:/temp/data services logon script.log. So we'll give that a few minutes and we'll come back when the automation is complete and look at the next steps. When all the deployment automation finishes, all the PowerShell windows will automatically close. You can see that since that's happened, we know the deployment automation is finished. So, and then the next step is to go ahead and open up Azure Data Studio. We open up Azure Data Studio. I should be able to go ahead and connect to the SQL Managed Instance that was deployed as part of the Jumpstart automation. And there we go. I can open up the databases folder and I can see the AdventureWorks database that we restored onto the SQL Managed Instance. We'll take a look at things like the tables in there, and everything looks good. So what we've done is we've used a Terraform plan to deploy a new GKE cluster on Google Cloud Platform. We've then used some automation to go ahead and connect that GKE cluster as an Azure Arc-enabled Kubernetes cluster. We then deployed a Azure Arc-enabled data services data controller, and on top of that, we deployed a SQL Managed Instance and restored an example database. So now that we've verified that everything has worked as part of the automation, we've got our sample database, we've got our Azure Arc-enabled data services resources running on GKE. The last thing we're going to want to do, of course, for a demo environment like this is tear it all down so that we don't have any ongoing charges on either Azure or on a Google Cloud Platform. So we can do that in just two simple steps. The first step that I'm going to do is I'm going to delete the resources inside the GKE cluster. So to do that, I'll open up a PowerShell window inside of the client VM. I'll run that as an administrator. And I'll just delete the entire Kubernetes namespace where the Azure Arc-enabled data services reside. To do that, I'll do kubectl delete namespace arc. It'll take just a few minutes, even less than a few minutes. It'll delete all the resources inside the GKE cluster. And the reason we're doing this is because as part of deploying the data controller and the SQL Managed Instance, Google Cloud Platform is creating storage disks that are attached to the cluster as part of the persistent volumes that are needed to run the data controller and the SQL Managed Instance. So this is just a good step to go ahead and make sure that we're not going to have disks that are left over hanging out in our environment. And another reason we need to do this is because the Terraform plan that we originally used to create the primary Google resources is not going to be aware of these disks. So when we run the next step, which will be the Terraform destroy command, it would actually miss these disks if we didn't do this step. So this step is definitely important to make sure that you clean up your Google environment. Okay, that's completed. We can close out the remote desktop window. We can pull back up our terminal window, and we can simply run Terraform destroy auto approve, and that's going to finish the rest of the teardown. So I hope you've enjoyed this video. As always, if you want to see more great content like this, please be sure to like and subscribe to the channel. We'll always have new, fresh Azure Arc content coming out every month. So definitely appreciate you watching, and make sure you also check out the Azure Arc Jumpstart itself, and looking forward to next time. Thank you so much.